The contents of lecture number 14 are finding an equation related to the roots of the given quadratic equation. Means to say, in the last lecture, we were given the roots of the quadratic equation and we were supposed to find out the quadratic equation with the help of those particular roots. Here we will be given another quadratic equation with the help of which we will have to find out the required quadratic equation. The second content of today's lecture is synthetic division and solving the sums related to it. So let's start with the first one. Exercise 2.5. If alpha beta are the roots of the equation x square minus 3x plus 6 is equal to 0, we will have to form an equation whose roots are 2 alpha plus 1 and 2 beta plus 1. Here we have been given the equation, and with the help of this equation and with the help of the sum and product of roots of this equation, we will have to find out the equation containing these roots. So let's start with the comparison. We get a is equal to 1, b is equal to minus 3 and c is equal to 6. Since it is given that alpha beta are roots of the equation, then sum of the roots will be alpha plus beta is equal to minus b by a. While putting the values, we just get minus into minus 3 is equal to plus 3. So alpha plus beta is equal to 3. Next, we will have to find out the product of roots. The product of roots contains c by a from the formula point of view. So alpha beta is equal to 6. Now we need to find out the equation whose roots are 2 alpha plus 1 and 2 beta plus 1. For this, we will have to find out the sum of these roots and the product of these roots. For this, first we find out the sum of these two roots. So let's start adding these two roots. Sum of roots s is equal to 2 alpha plus 1 plus 2 beta plus 1. It will be 2 alpha plus 2 beta plus 2. While taking 2 out as a common factor, we will be left with alpha plus beta inside the bracket. We are having the values of alpha plus beta and alpha beta, so that we may use for finding out the sum and the product of the roots of required quadratic equation. So here we can use, or we can put the value of alpha plus beta, which is 3. So it will become 8. So s is equal to 8. Now is the turn of the product of roots. We are going to multiply these two roots. After multiplying them, we get 4 alpha beta plus 2 alpha plus 2 beta plus 1. Here alpha beta is along with 4, means to say we are going to use, or we are going to put the values of alpha beta. So we will be having 4 alpha beta. While taking 2 out as a common factor, we will be left with alpha plus beta inside the bracket. After putting the values of alpha beta and alpha plus beta, we just have p is equal to 31. Now since we derived in the previous lecture that the formula which we use to find out the required quadratic equation is x square minus sx plus p is equal to 0. Now we have just found out the values of x and that of p. After putting those values in the above formula, we just get x square minus 8x plus 31 is equal to 0, which is the required quadratic equation. Part E is alpha plus beta and 1 by alpha plus 1 by beta. The sum of roots be alpha plus beta plus 1 by alpha plus 1 by beta. Then by adding these, we just get alpha plus beta whole divided by alpha beta. Putting the values of alpha plus beta and alpha beta, which we just found, we get s is equal to 7 by 2. Similarly, we will have to find out the product of roots by multiplying these two. For this, we will have to add these two, 1 by alpha and 1 by beta, so that we may put the values of alpha plus beta and alpha beta. Then we get alpha plus beta into alpha plus beta whole divided by alpha beta. So we have 3 into 3 divided by 2. So p is equal to 3 by 2. So the required equation is x square minus sx plus p is equal to 0. Putting the values of s and p in this formula, we just get the required equation as 2x square minus 7x plus 3 is equal to 0. Here we have multiplied this 2 to each and every term of the equation in order to make it or bring it in more appropriate form. Now is the turn of the next topic, that is synthetic division. Now what is synthetic division? It can be considered as a shortcut of the long division. So let's discuss synthetic division by the following definition. Synthetic division is the process of finding the quotient and the remainder. When a polynomial is divided by a linear polynomial, synthetic division is simply a shortcut of long division. We are not going to divide the given polynomial by a linear polynomial, but we are going to use the synthetic division, which is a new thing for you, to find out the quotient and remainder. So let's start using the synthetic division, or finding the roots or solving the equations by using the synthetic division. Question number 1 of exercise 2.6 is use synthetic division to find the quotient and the remainder when the cubic polynomial x cube plus x square minus 3x plus 2 is divided by the linear polynomial x minus 2. Here this cubic polynomial is to be divided by this linear polynomial. So it is the divisor and it is the dividend. We are going to find out the quotient and the remainder by using the synthetic division. For this, first we write that the polynomial containing x is the cubic polynomial and it is x cube plus x square minus 3x plus 2. Now let the linear divisor x minus 2 is equal to 0 implies that x is equal to 2. It is from the start is similar to the remainder theorem, but from this step it will be changed. Now here in the synthetic division method, we are not going to write the variable with the different powers. That is, we are not going to mention x over here. We are going to write the coefficient of x. First, the coefficient of x cube is 1. The coefficient of x square is 1. That of the coefficient of x is minus 3 and the constant is 2. Here we have to keep one thing in our mind, that if any of the term is missing, for example, if x square would not have been over here, we would have written 0 as its coefficient. So if in the sequence wise, if any power of x is missing, we are going to write its coefficient as 0. So here the coefficient of x cube is 1, that of x square is 1, that of x is minus 3 and the constant is 2. Our divisor is 2. The first number which we have is to be written down as it is. Since the arrowhead over here is indicating that, we are going to write this one as it is. So 1 will be written as it is. For the next step, we are going to multiply this 2 by this one. It will be 2 multiply 1 is equal to 2, and we will write this 2 beneath the next term, that is 1. So after writing this 2, we are going to add or subtract these two numbers according to the signs which they have. Since the sign with both the term is the positive one, so we are going to add this 1 and 2. So it will be 1 plus 2 is equal to 3. Then we will multiply this 3 with again this 2. It will be 6 and will be written beneath this minus 3. Now we have minus 3 and 6. One term is the negative one and another one is positive one. So we are going to subtract these two terms. After subtracting these two terms, we just get 6 minus 3 is equal to 3. Now this 3 will be multiplied to this 2 again, and we will get 2 into 3 is equal to 6. Now once again both the terms are the positive one. So 2 plus 6 will be equal to 8. Keep this thing in your mind, that the last term which we obtain after putting or after writing the value beneath the last coefficient, it will be considered as remainder, and the rest one or the remaining terms will make the quotient or the polynomial which is the quotient. So the quotient is, since we have the three terms and we know that the term containing the three terms or the equation containing the three terms is the quadratic equation, so we will start with x square and we will write as 1 into x square is equal to x square, 3 into x plus 3, and a remainder is equal to 8.